Thank you to my colleague, Michael Forrester, who is here to talk about AWS for data science, and he'll be talking about migration and also the certification, if that's something you're interested in. And we will start here in just a moment. We've got a big crowd today and people are filtering in. This is great. Thank you so much for being here again. If you're interested in any upcoming webinars, you can go to the WebAge site at webagesolutions.com/webinars. And all of our past webinar recordings are on our YouTube channel. Just a little bit about WebAge Solutions. We've been in business for over 20 years, and we do IT training all over the US, worldwide, and online for Fortune 500 companies and others. We also we focus a lot on AWS and cloud, but also Agile, DevOps, Microsoft topics, Java, mobile, pretty much you name it. We can create a class for you if you don't see it, or an upskilling program. And also just to let you know, we've have a couple sister companies now. We've got Accelerate.com, which has also been in business for 20 years, and Exit Certified, also 20 years of business. So we've got a lot of experience between us, and this just makes it better for you because now we've got more access to materials and trainers and certifications. So better for you. But today we're here to talk about AWS, and I will put this URL that's up on the screen in the chat. It's the AWS Machine Learning course. That course maps very well to this presentation that Michael will be doing today. And I'll also put something else in the chat. About 3 years ago, Michael and I worked together for an Accelerate webinar on EKS, and that was very well received. So I'm going to put that URL to the YouTube video in the chat for you in case you want to go back to yesteryear, but it's still very relevant, and it was a great presentation. So Michael comes to us as an Amazon authorized instructor. He's got over 20 years of experience in all things DevOps, AWS, Kubernetes, MLOps, AIOps, you name it. And he's been training for a while, but he also has a lot of real world experience that he can bring to the classroom. I won't read every bullet point, but he was a team lead at a Fortune 100 company where he was actually implementing this stuff. So not only can he teach it, he's going to bring a lot of real world experience into the classroom for you. And luckily for us, he teaches our official AWS courses and has helped thousands of students pass their certification. So with that, Michael, I'm going to go ahead and turn it over to you so you can dazzle everyone with AWS.
All right, fabulous.
All right. Here we go.
Okay. Well, welcome everybody. So it's a pleasure to be here today. We are going to be talking about AWS, particularly one particular segment, which is going to be about machine learning. So, you know, the idea today is to talk a little bit about the broad overview of, like, if you were looking to migrate or get into AWS, what kind of services would be available to you, especially when it comes to data science and machine learning workloads, or you know, AI of all of its different varieties, as it's become incredibly popular now. And then, of course, we're going to talk about the end about certification, just to kind of talk about what is the step-by-step process that you can use to actually pass the machine learning certification. And through that process, just become very well-versed, not only in machine learning in general, but just with AWS and its particular peccadillos around machine learning services. I am watching the chat and the questions, so if you ask a question at any time, I reserve the right to stop and answer it. Usually it works better that way. There also will be a Q&A at the end, so feel free to, you know, save your questions if you want. Maybe I'll answer them through the process. So let's dive right in. So when I was looking to craft this presentation, it's funny, I pulled up a web page from January of 2023, where, you know, before all of the explosion of both hype and substance that came with ChatGPT's kind of generative AI kind of explosion onto the scene, usually into like everyday people's lives, not just the tech world. And so this statistics are actually from January of 2023, which I find hilarious because they're probably wildly inaccurate now, and just in terms of the amount of investment that people are now looking at, not just with, you know, the fancier generative AI models, but just in the basic use of machine learning in and of itself, right? Which is, of course, the enabler for AI to happen. So, you know, here, you know, back in January, it's like 35% of companies were using AI. This is in January of 2023, and 42% of them were exploring for implementation in the future, right? So as you can imagine, that number is probably up by 50%, maybe double since the explosion of all of these models that we're now having conversations about. Obviously, it was showing that leading businesses are investing in AI at about a 91, 92% rate on an ongoing basis. And Gartner was telling us that customer satisfaction is expected to grow by a quarter in 2023 in organizations that use AI. Obviously, you just see it exploding now. It's almost to the point of like, well, I don't know that I can take another AI tool. Everything from Khan Academy to now, Amazon's now doing their whole Bedrock generative AI platforms. It's like it's just blown up. And so, private sector companies here, the last one, we're showing that 44% of them plan to invest in AI systems in 2023. Again, this is January, probably completely exploded to something more like 90%, if not 100, as the year went on. So I thought these statistics were interesting because they're probably wildly inaccurate, but even more likely now that people are investing in this area. So with that said, when we talk about AWS and the need for, machine learning, what are the components that we need to do machine learning? Like, what is it? What are the basic things that we look at to say, okay, I want to put some predictions, I want to put some probabilities, I want to do some prognostications, to use fancy words. I want to do some forecasting about some aspect of my business, and we're going to use machine learning for that. What do you need for that? What are the basic components for that to happen? Now, this comes off of a pretty staid model that was in Coursera, and I believe it also is on AWS. There's a lot of AWS marketing material about one. Obviously, you have to understand the business. Two, you have to have some understanding of the data that you have, and that typically you have to have some prep for that data. Are there gaps in that data? Is the data relevant for the business problem? But outside of those concepts, the basic thing that we're looking for here from a technology standpoint is that we need a place to store that data, a place to keep that data so that we can massage it, change it, pre-process it, extrapolate upon it, that kind of thing. So probably storage is probably one of the key components that we need for machine learning. Beyond that, then we have to choose our model or our algorithm that's going to give us the type of prediction, the type of with the inference, right, that we're looking for. And we've got to train data against that model so that we can get some training artifacts, some outputs, some weightings, if you will, to use the term loosely, that will allow us to train that model towards the outputs that we're looking for, towards the probabilities that we're looking for, towards the type of outcomes that we're looking for. And that requires a little bit of hosting, right? And so you might also, by the way, have some kind of mathematical model or some statistics that you're looking at for data visualization, some data reporting, some data products. And then, of course, outside of how you present that data and whatever productization you put on top of it, obviously in the training mode, you're going to have to validate that data. In other words, did you train the model to do the thing that you needed for the business? And how do you validate that the model will actually give you a highly probable outcome that you're looking for? In other words, if you can predict about 80 or 90% of the time that someone will buy a product if you give them this product, that's actually pretty good. But if you go and validate the model and you find out that only about 50% of the time or maybe 40% of the time it's going to match, that probability, that statistic probably isn't going to be very useful for your business. Maybe it is. It depends on the use case. And so you need some place to host that, some place to host the training of the model, the validation of the model, what we would call kind of like our training montage, if you will, around machine learning. It's like, how do we teach the machine to identify the outputs that we want and to identify the outputs that we don't want? And then last but not least is, well, once you've got it trained, let's say we're making superheroes. Once your superhero is trained, how do you deploy your superhero? Because once you deploy them, it's not just a matter of running 1, 2, 3, or 4. I mean, in the early days of this, back in 2014, I remember working with a recommendation engine that could make 3 recommendations a second. Now, as you can imagine, that wouldn't scale very well unless you were going to copy it over and over and over again, right? Like you were going to copy the environment to get to 300, for example. You'd have to require 100 times the hardware because it was pretty linear in scale. So when you get to deployments, there's different considerations because you're typically dealing with having to make probabilities, inferences, and predictions at a scale that doesn't exist in training. Training, you run, you train the data, you validate it. You could do that several times, like lather, rinse, repeat. But with deployments, you're actually feeding out, customer-facing outcomes. So you need to be able to be responsive to the customer with your deployments. And if you look, those things at the bottom are typically what you need. You need some storage, you need some compute and hosting, right, for the training portion, and you need some compute and hosting for the validation. I'm sorry, not for the validation, for the actual production deployment. And then who's going to orchestrate it all? Who's going to put all this together? Now, as you know, machine learning has been a hot topic, probably at least since 2016, 2017, when the machines were able to start identifying images at a rate that was better than human beings, or on par with human beings in some cases, right? But so machine learning has been on the table, has been something that people have been extrapolating and playing with for quite some time, even if it's just purely from a recommendations engine or forecasting space. So we've known that you need storage services to host the data, and you know that you need different types of hosting to do the training and the production deployment, and you need something that will orchestrate this whole thing from end to end, unless you want to do it manually, which of course the cloud providers are trying their best to make sure they take that off your plate, AWS in particular. But you might say to yourself, well, why would I just roll my own, Michael? Why do I want to do this? Why would I even consider, for example, giving this to AWS? Why would I look at having them do this if it's so well defined? And the challenge here is that AWS, in many cases, is going to offer the kind of scale and performance that you typically won't have available in your data center. And so when we talk about the services and we talk about SageMaker and some other things here down as we move forward into this, you've just got to know that if you want to kick up 1,000 machines and have them run for 6 hours on some kind of batch inference or training data, you can do that. You can do distributed training inside of AWS. It's typically going to be high performance. You're going to get very scalable network performance. I mean, amazing 20 gigabit backplanes, all just really at scales that I have to say, when I was running my own data center, I just wish was the standard. And then you're going to get things like, near infinite access to, object-based storage, like with S3, which we'll talk about here in a bit. And this is great for creating data lakes, for data classification, for managing labeled data, for massaging data, engineering, feature engineering data. There's just tons of opportunities here. In addition, if you do not treat AWS, one, like a panacea, and two, like just another expensive data center, if you actually learn the pitfalls, the cons, and the pros of running stuff on AWS and how to do it as if you were actually doing it cloud native, it can be cost effective. If you just use it like another data center, then unfortunately it just becomes expensive data center 2.0, right? And it is worth noting, by the way, that Amazon has done things like release these Trainium processors that are kind of uniquely designed for ML workloads. They have a ridiculous scope of GPU instances available that are very cost effective and available at scale. And of course, there's all the tips and tricks around running spot instances versus savings plans versus the flexibility of being on demand that you can use as well, as far as like why AWS might be a good choice for this. And probably last but not least is that when it comes to ML workloads, AWS is highly flexible. So not only will it support pretty much all of the major learning frameworks, you can bring your own custom Docker images in, and as long as you are using the SageMaker tools to wrap around into that container, along with whatever framework you're bringing, you're going to have a good experience, and it's going to be performant. It's going to integrate really well with AWS. Of course, I say that there's always edge cases where there's some difficulties, but for the most part, if you're using the standard well-known frameworks like TensorFlow and PyTorch and MXNet and Gluon and all that, you're gonna have an amazing experience on AWS. In addition, AWS has an SDK called Neuron that really helps create low latency interactions with SageMaker and some of its kind of GPU-based instances. And then it supports some of the kind of recent NVIDIA collective communications library along with the Elastic Fabric adapter in order to really create the ability to share GPUs across distributed systems in a way that's actually very performant. So, okay, so that's enough about why maybe AWS might be a good choice. What are the actual services that we offer? Because Michael, you just said something about storage and you just said something about hosting. What are we talking about, right? So generally, and this is not meant to be an exhaustive list, just so you're prepared, at the very end of this slide deck, there's actually an appendix that lists every single machine learning and every single subservice of SageMaker, every AI and machine learning service is listed at the very end of this deck so that you can get a very clear definition of every single service inside of AWS because the list is extensive. Now, that being said, let's start with workflow at the top. So as you can see, there's a list of services here. SageMaker, there's deep learning AMIs, which are these bootable machine images that are optimized for machine learning workloads. There's also deep learning containers that you can download publicly as well. There's a batch service that will allow you to distribute and batch out jobs, and that includes calling SageMaker jobs if you want to. So you could batch, 1,000 SageMaker jobs together if you wanted to. There's Parallel Cluster, which is a framework for creating high performance clusters. And then, of course, there's the container services, which Kubernetes and the Elastic Container Service are the two primaries. Kubernetes tends to dominate in the space when it comes to like kubeflow and MLflow, that kind of thing, just because it is actually a comparable or certifiable upstream Kubernetes distribution. And then we've got EMR, which is a little purple icon right there, which is Elastic MapReduce, which has been around for quite a while, but has iterated provocatively, making pretty much most of these frameworks available on it. One of the ones that's missing here that I think is also worth mentioning is one called Glue, which is really just it's like PySpark really. It basically allows you to run all kinds of ETL jobs on AWS. And then of course we got the frameworks, which we talked about before. And then notice that there's a bunch of EC2 instance types like the P4s and the P3s and the G4s, and these come with either GPUs or processors that are purpose-built for machine learning workloads. Notice that I put an X on Elastic Inference. That's because that product is going away. They just announced that fairly recently. They actually want you to use the EC2 instances that have GPUs instead of using Elastic Inference, which was a way to attach GPUs to any EC2 instance you had. And then you'll see in the green a whole bunch of storage options, of which S3 is probably primary, but EFS in particular is probably a great second cousin there, along with FX, which has 4 different flavors to it. FSX has particularly Lustre, which if you're into high performance computing, Lustre is very attractive. Now, that's a general overview of the kind of things that AWS offer. Let's get into a little specifics. If you're looking to prepare your data and ingest it, right? So this is where the data scientists, spend their time, exploring data, pre-processing data, wrangling data, kind of getting that data from model processing. You typically are going to fetch that data into a repository, clean the data by filtering it, doing some feature engineering, modifying the data so that it's easier to ingest and there's no kind of outliers that might skew off your outputs. You're going to do that basically with a variety of different tools. And here AWS provides, Mechanical Turk, which, if you need, for example, to do some kind of manual data labeling, they can do that as, with Mechanical Turk. They also have a manual data labeler called SageMaker Ground Truth, which is one of the tools that is part of the SageMaker kind of macro service called Ground Truth. And then SageMaker itself is pretty much a tool that has about 17, 18 other subservices underneath it, of which one of them is processing, there's training, there's modeling, there's model registry, there's all kinds of like cool stuff under SageMaker. And so here we're talking about the processing, which basically gives you this fully managed experience to basically spin up distributed workloads, process them, and then spin them down when you're done, which can be very cost effective. And then EMR I mentioned before, which is basically MapReduce. Spark is in there. I think Fink is in there as well. But basically, it's used to process data, massage it, manage it out, particularly at large scale data sets. And of course, I mentioned S3, which S3 is pretty much the infinite storage repository that AWS touts as like, well, you can put as much data as you want up there as long as you're willing to pay for it. We always wanted to kind of test that and be like, well, I just won the lottery, so I'm just going to stick $1 million worth of files out there and see what happens. Now, I say that I've stuck petabytes of data out on S3 and not had any performance problems, but yeah, always wanted to test and see like, what happens if I put an exabyte of data on S3? Now, to give you an example, since this is part of the preparation of data ingestion, right, and data management, data massaging, if you will, here's kind of like a possible diagram that you could consider, and notice here that you've got SageMaker in the upper left-hand side, you've got your Jupyter Notebook, you've got the Glue Data Brew, right, which is all about data wrangling. And notice the arrows here is that, ignore the SAP, that could be any application. We're not picking on SAP on this, right? But let's say that, this data is being extracted from SAP, going into S3, so it's going into kind of an inbound bucket, and then it's going into Data Brew, which is then massaging and wrangling the data to a certain type. And maybe you've got a Jupyter Notebook in play because you want to take a look at the data and you want to run, scikit-learn and Seaborn or whatever it is that you're running to kind of massage and manage and visualize the data. And then, maybe kick it over to SageMaker, which, does its training, modeling, processing. Some of the artifacts land here, maybe there's some outputs here, and you then import that data into SAP. This gives you kind of a very light and general way of how S3 and, for example, Glue could be used to ingest, massage your data, and then kind of get it back out to, a system of record, in this case, SAP, right? Let me just check and make sure I didn't miss any questions. I think we're good. All right. So that's an example of potential data ingestion. Okay. Seem to be running into some bandwidth problems. Hold on just 1 second. Turn my camera off for a second. There we go. Okay. All right. Oh, sorry. Ran into a little bandwidth issue there. Hopefully that will continue to clear up. Okay, so let's talk about then, now that we've got some data, what if we want, what services would we use to build our model? Well, always know that because it's AWS, you can always run your notebook on whatever EC2 instance of choice you're looking for. So don't feel like you have to be constrained to SageMaker or any of the higher managed services. You can run on whatever it is that you want to run on, right? So if you want to run on a virtual machine of your choice where you control the environment, you can do that. If you want to do ECS or EKS and run your own containers, you can do that. If you want to run, virtual machines and containers that are managed by SageMaker, you can do that as well. So just know that raw infrastructure is always a choice that you have on the table. It may not be ideal or cost effective from an operational standpoint, but you get more control. And so if that's a requirement, there's nothing wrong with that. Now notice here, when building your model, you've got obviously plenty of opportunities to use Jupyter Notebooks. You can also use pre-built, algorithms. Pretty much all of the industry standards are there. And then of course, SageMaker will help you, configure and manage all of these leading frameworks. I mentioned before about both deep learning machine images and deep learning containers, because you've got these EC2 instances and these Docker images that are pre-installed with all of those frameworks like TensorFlow and PyTorch and Apache's MXNet, like things that we were talking about before. So you could use these options to build your model. And then from there, just to give an idea of what might be possible from a diagram standpoint, is that here you could build your model using that S3 bucket. And again, you see Data Wrangler, which is that Glue product, which is kind of massaging the data. It's going into the S3 bucket, and then you see the SageMaker processing happening, which is, again, being helped and managed by a notebook. And then what's happening is that you're storing it into an end feature like Data Store, capturing the outputs and using them in your business. And then after you've built your model, some things to then look at are things like, oh, well, how do we train? And when I say train, we're talking now about the storage portion of the training, because I mentioned S3 before, and I also mentioned that there's FSX for Lustre, and there's EFS, which is like NFS file system, and then there's got these really fast hard drives, which are probably the most expensive of the storage that's here, but can get you really fast storage really quickly. There is an option if you need machines that have fast SSD-based drives against them. I saw one of the EBS volumes the other day. It was Block Express, actually, and it was a special type of provisioned IOPS on the EBS family, and it had 256,000 IO per second, and the transfer size was like 256 kilobytes or something. It was something ridiculous. And I was like, 256,000 IO per second. That is a crazy fast disk. So, those are the kind of options that are available to you on AWS. Obviously, you'll pay for that, but you also know that there's also colder types of storage that are great for archival. And of course, S3 is performant for machine learning workloads, but it's also cost effective in that it has data tiering. So you can actually tier your storage in S3 if you want to make it really cost effective for your machine learning workloads. Now, here's another example diagram as it kind of flips forward here for just a second to show you what could be possible from with S3 in terms of, you've got a camera on the upper left-hand side, and it's, converting video to maybe to frames, like picture shots, and those frames are going to end up in S3. And then notice that there's a bunch of jobs here that maybe like ground truth is going to go and label these pictures and label these videos, and there's going to be some annotations. And then that's going to get picked up in the upper right-hand side because that's the whole preparation of the training data. And then what happens is that the data is then going to be fed into the SageMaker training service, which is then going to train the model artifact and make sure those outputs are actually stuck into an S3 bucket that can then get picked up by another service. For example, let's say it's Lambda running on IoT Greengrass, in order to be able to use the particular model outputs or the training in question. Now you could also, by the way, just feed that to a SageMaker deployment, where SageMaker is actually just running a container or a virtual machine that's using that data to basically give you the predictions and the inferences that you want. But in this particular case, they didn't do that because they used the output of the frames to basically help identify objects. So they pushed object detection modeling to the edge in this particular case. Now that was training storage. Let's talk about training compute for a second. So we already mentioned that you can run your own EC2 instances, right? We were already very upfront about that. You can always run your raw infrastructure if you want to. And here, by the way, there's tons of options, of great options here. Now notice there's P4 instances and there's P3 instances, and you can look that up. And these links are active inside the slide deck, but you can look up and see exactly what an EC2 P3 instance has in terms of GPUs. But as you can see here, this list also tells you what's there, right? It tells you, for example, that the P3 instances have up to 8 NVIDIA V100 tensor cores in them, right? And the backplane on these is 100 gigabits of networking throughput. Same with the G5, same with the G4s. You can actually see what it is they have available. So notice that SageMaker isn't listed here, but once again, SageMaker runs EC2 instances. You can also run containers. It usually typically runs containers in those instances, but it runs virtual machines. So in a diagram like this, you can already know that if SageMaker is present in the service, then some kind of virtual machine sizing that you have chosen is here and is running. And so do know that you will want to choose the appropriate virtual machines that's sized for the type of job that you're running. How do you know what that is? Well, in some cases, it's experimentation. In some cases, you can look at the vendor documentation as an example and kind of get an idea of what your time frames are and what kind of horsepower you want to throw at it. So that's train as it relates to compute and as it relates to storage. Let's talk about a little bit of orchestration. So one of the interesting things about orchestration is that, especially if you're using something like SageMaker or the Elastic Kubernetes service or Parallel Cluster, these frameworks are there because they can help you orchestrate the entire pipeline of what you need from, pre-trained data, training, and then deployment. They can basically help you with that whole pipeline. And, AWS Batch, for example, is really available for very massive data sets like large scale training. And it can literally call SageMaker to run and process portions of the data set that you're looking to train. Here's an example in this picture here. You'll see that, there's some kind of data that they're wanting to pull from Amazon Aurora, which is a MySQL or Postgres clone. And it really runs at scale. It's a very kind of amazing product, actually. And they have a serverless version as well, which is kind of nice. And so someone runs a query in order to pull back this array of data, and it's massive. Aurora can have volumes up to 64 terabytes in size. And I don't remember what the latest size of tables and indexes are, but it's pretty big. But especially if you're doing a complex join, a query of some sort, you can be pulling from a bunch of different tables across the entire cluster. This could be a massive data set. Here, AWS Batch is being used to kick that data set out across a bunch of SageMaker jobs. And notice those jobs are using P3 instances running from one S3 bucket has the input into SageMaker, into these P3 instances, which are going to distribute and process it. And then the output is stuck back onto an S3 bucket. And so that kind of orchestration can easily happen when you use things like Kubeflow with Kubernetes or Batch, AWS Batch, or SageMaker, especially SageMaker pipelines, or even Data Wrangler, which has its own pipelines, or Glue, which has its own pipelines. So there are a bunch of different ways to approach this. Probably last but not least is when you're training data, what about your utilities and your helpers? You might say, Michael, what do you mean utilities and helpers? Simple things like model tuning. Let's say you find out that you need to maybe tune your parameters on your model a little differently so the algorithm runs a little bit more efficiently. What if you need a debugger, right? Because you've got some weird outliers and anomalies in the training process. What if you want to experiment a little bit? What if you want to, push some outliers in, bring some outliers out? What if you want to run some experiments to see if you can either improve or clarify your outputs? So SageMaker experiments, these kind of utilities are very helpful. Notice that all of these are just products of the SageMaker moniker. So this is 3 of the 17, 18 subservices that make up SageMaker. Okay, here's a picture to go with that utilities piece. So notice here that you got a notebook, right? And that notebook is creating a tuning job. And here it's actually calling SageMaker's automatic model tuning, which is basically going to use particular techniques to test the parameters to see how they can increase or decrease probability in the predictions or the inferences that they're making. So you get a bunch of training jobs that are just going to run through this whole process of trying to see what works better, what works worse, and kind of learning from its outputs so that it can auto-tune by seeing what makes things worse, what makes things better. And of course, you can see the model tuning calling a bunch of SageMaker training jobs there. Now, the last thing outside of training is probably the most important one, which is, okay, what utilities, Michael, can we use to deploy our trained model into production? Well, I do want to let you know that, first of all, Elastic Inference is off the table. So you're not, the Elastic Inference, which is that one down there, you're going to see a couple of X's show up on it if you don't already. Just know that that's being retired, so you're not going to see that option. But notice that you can choose any of the options there for your SageMaker deployment. And the cool thing about is that when you deploy with SageMaker out into production, you get this thing called an endpoint, and this endpoint can have any number of SageMaker EC2 virtual machines behind it. So you could have 2, you could have 100. It means it's basically going to scale so that when your application comes in and says, hey, is John Doe going to buy another hat from me because he already has this cool red hat that he really likes, and you've got 1 million of those requests, you can actually use this abstraction point, if you will, to hide the number of virtual machines that you have, because you can grow them up you can scale them down, and it allows you to scale. And so as you can see there, the deploy on SageMaker hosting, notice it has that little like almost like pentagram at the top, little star, and it goes down to 3 little virtual machines basically. There could be 1,000 there could be 2, there could be 3. It can scale up and down based on the parameters you set. And by the way, there's that Neuron SDK that I was just talking about that allows you to integrate into machine learning on SageMaker very easily, very quickly. And it especially takes advantage of the Trainium processors that AWS designed. Okay. And I've already kind of touched on this a little bit, for this is the last topic as far as deploying at a rate, is basically around scaling. Know the auto scaling, which is the thing that I was just kind of alluding to just now, where you can kind of elastically scale up and down. You can put things into a fleet. You can put things into a fleet and run some things on what they call spot instances, which are incredibly cheap, but they're ephemeral. And you can run some of your models on demand. You can run some of your models on reservations. You could have all kinds of licensing models for SageMaker. So just something to keep in mind. And notice the last two, which is basically model monitor, which is going to monitor the inferences to make sure that everything is solid, and a multi-model endpoint, which allows you to do A/B testing or to test different models at scale to see what kind of customer experience they have when you deploy different models. So there's some great kind of tools here for A/B testing around customers as well. Here, by the way, is just a very simple diagram just showing that model endpoint that leads to a load balancer that can go to whatever number of machine learning instances at whatever scale you need. So it's kind of useful. Check it in to see if there's any questions. I don't think I see anything here. Good. All right. Okay. So let's talk then a little bit just about migrating workloads, because I wouldn't say that they're clean, like there's no tools to be like, okay, I've already got an automatic tool to migrate my massive machine learning workloads over to AWS. Don't get me wrong, there are application migration tools, there's database migration tools, there's entire data center migration tools that will literally allow you to copy a data center block from block from AWS, from your on-premise data center over to AWS. I mean, block for block replication. It's pretty nice. Those can all be used to migrate your ML workloads to AWS. But again, we're talking about data scientists and machine learning specialists and engineers and ML ops. A lot of it's centered around things like Jupyter notebooks, for example, where people have massaged their model and feature engineered their data and done all their things in these Jupyter notebooks. And it's relatively simple to migrate these Jupyter notebooks over to AWS, particularly if you integrate in with SageMaker. I guess the thing I would caution against is that there are no really like slick tools to just pop it into AWS per se. It's usually recommended that you kind of recraft or recreate your model that you already have, just recreate it on AWS, because you're going to find some efficiencies on AWS that you're not going to find on premise. I know that sounds like a very arrogant statement, but it's happened every time that I've been involved in an ML ops or data ops kind of program. Every time there's like, wait, you don't need to do that anymore? It's like, no, S3 will handle that for you. Well, what about data classification and tiering? S3 has lifecycle policies that will handle that for you. What about cross-regional replication? Like we want DR. You can actually set that up inside of S3. That'll be fine. That discussion, that was just S3 that I was talking about, happens all the time with like SageMaker, auto-scaling, Glue. You just find that these services have been purpose and custom built to be highly reliable, secure, and scale really well because it's AWS. And complain what you will about AWS's weird marketing and sometimes their inability to maybe not convey to customers all the products they have. If there's one thing that AWS does really well, is scale. They do actually scale really well. I was talking to someone the other day, and a buddy of mine who works there, and he was dealing with 1.75 million databases in just one of their regions. And I was like, ooh, that's a lot of databases. So migration typically involves let's repurpose it. Let's lift and shift it over to AWS. Let's recreate it over there, because this is really what you want. And AWS will do most of this for you if you just set up a few pipelines and some automation. That's it. And so it really is a very different beast when we talk about migration and whatnot around this over to AWS. One of the things I promised that I would mention is that, so there was a question about like, well, what if we want to do batch inference where we have a whole bunch of questions? Like we want to know what these 20 people are going to do in relation to a hat versus I just want to be able to ask like when that person comes and shops at my website, which is be like a real-time inference, right? Inference, by the way, is like a probability or prediction. Think of it as an output. An inference is just a machine learning output. It basically says, what is the likelihood that this person is going to buy this hat? And they'll say like, well, we think that if it's the brown hat that has the beaver thing on it, it's an 89% chance. That's an inference. Or they might come back and say, you know what, if it's got that beaver thing on it, it's probably going to be a 60% chance for this person. And so an inference is really just a statement of probability with usually a confidence score attached to it, right? That basically says, we're pretty certain, we're 89% sure this will happen, or 60, 50, whatever the number is. And so batch versus real time when it comes to AWS is honestly just not that big of a deal, both in terms of data ingestion and in terms of performance, like real time performance. So, as you can see here, it's like, is this live traffic in the upper left hand side? No? Oh, well, let's just batch transform that, and maybe we'll stick it into a database, and when that person visits our website, we'll just pull it from the database, right? Or it's like, no, this is live traffic. Like I need a prediction now of what this person is going to do. And then you come down, are you just running one model? Oh, well then let's just take a look at the SageMaker endpoint, because that's all we need, right? We'll get one endpoint and we'll ask the machines there for probabilities. We're going to load test just in case, and you just give us a response. Or if it's multiple models, you might have a multi-model endpoint where there's multiple versions of the model back there, and you might ask all of them. You might ask like 3 versions of the model. Hey, what do you think about this? And then you might like do some collation before you present it back to the user, right? So just know that batch versus real time is not really that big of a deal. Okay, it's probably time for us to talk then about the certification now that we've kind of gone over the general scope of services that can cover AWS. And I before I get into this, I just want to point out, we didn't talk about Poly, right? Which is like, text to voice, right? We didn't talk about Textract, which is able to extract text from images. We didn't talk about transcribe or translate. We didn't talk about Lex, which makes conversational chatbots. Just know that there are a bunch of very specific purpose-built services for AWS. But if you're looking to kind of just run your own machine learning models, then SageMaker and all of its amazing friends, that's going to be the king and queen of the services that you want to talk to, okay? But just know that there's far more. I mean, we've been here for about 40 minutes now, and we just basically went through a bunch of SageMaker related services. Just know there's a lot more, and they're all in the appendix here. Now, any questions about any of that before I talk about the machine learning specialty exam and ways in which you can pass it? No? Okay. All right. Well, then let's talk about, let's see. Oh, my camera turned on for a second. Hold on. Let's turn the thing back down because I think this is slowing my machine down. Okay. So let's talk about step 1 for the exam. Okay, so when we're talking about taking the specialty exam, one thing to know is that this is a 170-minute exam that has it's like 75 questions to it. But here's the cool thing. the first thing you want to do when to prep for any exam around AWS is that you want to get the exam guide. And the exam guide is going to contain some really cool things. So let me see if I can pull it up. Bear with me just one moment. Huh. Let me just stick with this for a second, because for some reason GoToMeeting is struggling just a little bit. All right, let's see if we can get back to where we were. So step one, by the way, is get an exam guide. And I have a sample of the exam guide down here so you can see it. But basically, the idea is that the exam guide is going to tell you exactly what they're going to ask you about. They're going to ask you about data engineering, exploratory data analysis, which, by the way, includes Python and knowing like how to massage Python with scikit-learn and Keras and a bunch of like knowing how some of the models work, the frameworks, not the models. And then domain 3 is about modeling. So this is where the algorithms come in. And then domain 4 is about how to implement operations, monitoring. How do you know that you have good outputs? So the first thing to do is get the specialty exam guide. The second thing to do is to get the AWS machine learning ramp-up guide. Now, this link is at the bottom of this page, but you can find this very easily. And this is what it looks like. This, by the way, contains digital trainings, most of which are free, as well as an amazing YouTube channel by AWS, which will teach you probably most everything you want to know about machine learning for free. It is about 30 or 40 hours worth of training, though, so be prepared. And then there are some classroom trainings here. So you can see SageMaker Studio for data scientists. Those are all official AWS classes. You probably want to come to someone like us to take those. I would tell you that you don't need to take every single class they recommend. I would probably recommend taking one, like practical SageMaker for data scientists, right? That would be a good one to take. But this ramp-up guide is going to give you a step-by-step guide of what to study. It's going to talk about comprehend, which I didn't talk about. It's going to talk about text extracts. It's going to talk about poly. It's going to talk about these kind of, single-use ML services that AWS has made very easy to consume. And so the ramp-up guide is going to be incredibly helpful for that. So you've got your exam guide, which is going to tell you about the exam, and then you've got the ramp-up guide, which is going to teach you how to study. It's going to give you the step-by-step for studying. It's going to tell you what to study. Now, in terms of how to study, well, the general rule is schedule your week out. Carve out 3 to 5 hours a week. Do a little bit every day if you can, and look at the content, test the content if you can, go through the content, just kind of put your hands on it, play with it, experiment with it, and get to learning, because that's going to be where the theory and all that you learn inside those classes is going to be essential for when you get onto this step, which is getting hands-on. And this is a bunch of hands-on workshops that you can run in your own AWS account that will typically cost you less than 50 cents. But like different workshops, SageMaker workshop, and the first link in particular, workshops.aws, is going to take you to a bunch of AI and ML workshops. And so you can really get hands-on. You're also going to find a bunch of hands-on stuff inside the actual ramp-up guide that you saw here. There's going to be a bunch of self-paced labs and other things that you can do that are just fabulous for driving this deeper. Remember that you have to have 2 years experience running workloads on AWS to take this exam. They don't test you on that. They don't check, but they assume that you've been working with AWS for 2 years before you take this exam. So if you don't have that, make sure you do as much as possible hands-on work as you can to be comfortable with AWS. So step 1 is get the exam guide. Step 2 is to get the ramp-up guide. Step 3 is to schedule material. Step 4 is to get hands-on with the material. Step 5 is to get some practice exams. Now, I have no affiliation, neither does WebAge, with Tutorials Dojo, but Tutorials Dojo, hands down, no doubt, has the best specialty exams that I've seen. Better than Stefan Merrick, better than, people come to me all the time. I'm probably familiar with the person in question. And I mean, I used these exams to pass my ML specialty exam in January of this year. So yeah, so I have some experience with that. So like notice here for this one, this is what they do is they ask you the question. They said they want to track and record the number of deployments performed, the CPU, GPU utilization, as well as the number of invocation errors. Well, that's going to be CloudTrail and CloudWatch. And so what will happen is that you'll notice that CloudTrail and CloudWatch, and I'm sorry for the shifting, but the image was a little too high res, but they're going to tell you what the right answers are. They're going to tell you why they're the right answers. And on that same page, they're going to tell you why X-ray, config, and inspector are the wrong answers. So you're going to learn not just the right answers, but the wrong answers. And through that process, you're going to learn something about AWS. It's not just sit here and straight memorization. You're actually going to learn what the services do and what they're used for. That's step 6. Step 7 is all about celebrating and scheduling your tests and celebrating your passing, because what we're looking for here is that we want you to get a 90% on 2 of these practice exams that we were just talking about. We want you to get 90% on the 2 of these review mode exams. You're going to take them again and again and again until you get 90%. And then once you're done, you're ready to take the tests. But that's only after you have looked at the exam guide, done the training in the ramp-up guide, done some study for weeks, usually about somewhere between 6 to 12 weeks, depending on how much time you have, got a little hands-on, taken the practice exams until you get that 90%, and then you're ready to go. You go schedule your tests, and your probability of passing is very high. Nothing is guaranteed, but we've passed hundreds, if not thousands, of students this way, and I personally have passed thousands of students, using this kind of 6-step method, if you will. So with that all in mind, we're now open for Q&A, and I actually saw a question pop up. Let's see, Mr. Slaney, you said, how do we get increased exposure to these services or tools at minimal cost? So do note that most of the AWS accounts have what's called a free tier. And I'm going to see if I can't pull that up again. Let's see. There we go. So there's a free tier account, and what happens is that when you get a free tier, this is basically the minute you create an account, you basically get access for 12 months to a bunch of services. And you can come here and see which ones are free. But like, for example, SageMaker, I don't know if SageMaker is on the list, but it looks like you get 2 months of free SageMaker data at 250 hours per month at this size, right? And that also is true for Ground Truth as well. If you want to basically limit it to machine learning, right? They'll say, hey, oops. Comprehend will give you 50,000 runs. Comprehend Medical, there's Lex, Poly. This is all free, right? So you can play with this free tier up to these limits without paying for anything. I will also tell you, by the way, at the scale that most of us play at, these are not going to cost you maybe but pennies at most, because these are on-demand services, meaning you run them, they get your request, they feed your output, and then they stop running. The only thing you have to be careful of is that SageMaker has instances attached to it. So if you start a SageMaker instance, just make sure you stop it before you walk away. Or even better, set it to auto expire where it will actually shut down and stop itself. And then you can start it back up when you want to continue your journey, right? So Corey, that's probably one of the best ways to get access to these services. Also, it is worth mentioning, and let me see if I can pull that up as well, is that these workshops that I linked you to, right? These workshops are extremely useful for getting access, and they'll typically cost you pennies on the dollar. So these are all the AI ML workshops. So here's Lex, here's SageMaker Feature Story, here's some Data Brew stuff, here's SageMaker Studio. Like, these are going to cost you 4 hours. They'll probably at most cost you 50 cents. No, the free tier is still going. The only thing is that it has to be an account that you created new. So if you have an existing account, you want to go create a new account. Otherwise, the free tier expires after 12 months. And when I say the free tier expires, portions of the free tier expires. Some of this stuff is always free, Some of it's only free for 12 months, and some of it's unlimited trial. So if you find that you're not getting any discounts at all, nothing seems to be free, go create a new AWS account using a new email. If you're like me using Gmail, by the way, you can just put a plus sign after your name and it'll look like a different email. I'll give you an example. If you were, for example, were aws@gmail.com, which would be pretty bold, you could just do plus Corey@gmail.com and it'll look like a new email address to AWS, but it won't. Yeah. So I would start a new account, Corey, if you want to get those discounts. I actually run an AWS organizations, and I just create a new account every year under the organization. So that way, everything I run, I just run into that new member account, and it runs cheaply, right, at scale. Good. Other questions? Good. Good. I do also want to point out that this is, well, let me swap that so that looks better. This is the appendix. And in this appendix, by the way, is a glossary of all the AWS AI ML services. This is SageMaker. Here's Augmented AI. Here's Code Guru. So for some reason, you need to know these. They're all listed here. Fraud Detector, Kendra, Personalized, Poly, Recognition. They are all over the place. So Textract, Transcribe, Amazon Translate, Deep Composer, Deep Lens, Deep Racer. Deep Racer is fun, by the way. Panorama, Monotron, which has a variety of different pieces to it, and then Health Lake. And then past this, once you get past Lex and a couple of the other things, there is a glossary of SageMaker services. So SageMaker, here's Canvas, here's Ground Truth, here's Data Wrangler. So if this is something that you need to know because either you're taking the architect exam or the professional, or you're taking the machine learning exam and you need to know what these things are, these are all available to you. From my understanding, I believe they are going to get emailed out. If you don't see them, then all you need to do is email me at michael@webagesolutions.com, or you can catch me at LinkedIn. My full name is Michael Rishi Forrester at LinkedIn, and you can just catch me there, and I'll make sure that you get a copy of the slides in PDF format. So Michael@WebAgeSolutions will get you to me. Wait, is that right? Hold on. No, it's not Michael@WebAgeSolutions. It's Michael.Forrester@WebAgeSolutions. So let me type that again. Sorry, I was getting confused with something else. Michael.Forrester@WebAgeSolutions.com will get you to me. Okay. All right. Well, if nobody has any other questions, I'm still hanging out here in case anybody wants to ask me anything you want about AWS, machine learning, any of it. Okay, getting back to this. Do note that you'll probably get a slide, invitation to take a survey. If you are interested in other courses or a deeper dive, or you want, an 8-week coaching session on machine learning, or you want a deeper dive into Lex or Poly or any of those services or anything related to Kubernetes or DevOps, feel free to ask. Know that they are very responsive, and usually the CEO of WebAge reads every survey. So, feel free to put in there something that you're looking for. Otherwise, that's the end of our presentation. I'm going to hang out here for about 1 minute more in case someone has some questions. Otherwise, we are all done. Thank you so much for being here, and we'll catch you on the next webinar.